Hi guys, we're going to work on solving trig equations today. Now you will have actually done trig equations before, okay, and actually over the last about week when we've been solving for missing angles. So it really isn't a whole lot new about it. So let's take a look at example 1, you'll see what I mean. All right, we want to get the cosine of theta by itself, so we're going to add 1 and then divide by 2. Now this is looking a lot more like our trig equations that we've been working on so far. So we're going to try to think about where is x a half, because remember the definition of cosine is x. So where is x a half? So thinking about your unit circle, where is x a half? Well, that's at 60 or 300. And that's it. That's all it is to solving a simple trig equation. Now try example number 2. Keep in mind with this one that you're working with cosecant. So once you get it solved, you might want to flip it and convert it to a sine function to make it easier to find on your unit circle. You can check your answers to all of these even numbered examples at the end of the PowerPoint. Okay, example number 3. Similar problem, except this time we're working with tangent, and you'll notice it says tangent squared. So the first thing we're going to do is we're going to add 3. From there, we're almost done. We don't really want tangent squared theta equals 3 because I don't know what that means. So what we're going to do is we're going to take the square root of both sides and so that we get the tangent all by itself and not a tangent squared. So if I take the square root of both sides, I'm going to have tangent of theta equals plus or minus the square root of 3. Now, tangent is a tricky one because it's a combination of sine and cosine, so it's not as easy to deal with. But keep in mind that the only thing we have as far as sine and cosine are concerned that involves the square root of 3 is 1/2 square root of 3. So we must have started with that on the top and maybe a 1/2 on the bottom, and then the 1/2's canceled out. So what that means is that sine started out as 1/2 square root of 3 and cosine was a half, and when we put them together to create tangent, we canceled out the 1/2's. So looking at your unit circle, find where y is equal to 1/2 square root of 3 and where x is equal to a half, and you will find the tangent angles the angles for which tangent is that square root of 3. Now that's going to happen at 60, 120, 240, and 300. Now notice this time we had 4 answers. Well, that's because of this plus or minus. We could have sine be positive and cosine be negative, sine be negative, cosine be positive, or we can have them both positive or both negative. This plus or minus means we can work in all 4 quadrants. So I literally just looked at where is y equal to 1/2 square root of 3 and x equal to a half all the way around my circle. Now that happens whenever you take the square root. So in this next one, notice that we have cosine squared theta. Well, when we take the square root here, we're going to end up with 4 answers also. Try it and check your answer at the end of the PowerPoint. Let's move on to example number 3. Now these are all getting a little bit harder as we go along, but these are basically the only types you're going to see and you'll be okay. Now this one's still involving tangent, but notice this time I don't have tangent squared, I have tangent to theta. And you'll see how that affects our answer in a minute. First thing we're going to do, add 1. So that means that the tangent of 2 theta is equal to 1. So again here we're thinking about tangent, tangent being sine over cosine. So where are sine and cosine the same? So that when we cancel them out, we'll get a 1. Well, in order for them to be the same, we'd have to be working at a 45-degree angle, which means that the sine and cosine would both be 1/2 square root of 2. 45-degree angles, or angles with 45-degree reference angles, are the only ones that have the same sine and cosine value. So that's always going to be your 45's. Now we want them where they're positive, which is in the first quadrant, and where they're negative, both negative, which is in the third quadrant. So that is 45 and 225. Now, we're not quite done, because remember I told you this 2 theta was going to play a role in this. What we've done is we've solved it and we found angles 2 theta equals 45 or 225. We really want theta all by itself. So to get that all by itself, we're going to divide by 2. So when we divide by 2, I get my theta as being 22.5 or 112.5. Now, this 2 theta isn't too hard right here, but it actually makes the problem very tricky. We're trying to find all the angles between 0 and 360. But because I'm dividing those by 2, I can actually go all the way up to 720 with these. So here's how I'm going to find the others that work. Okay? I'm going to think about going around the circle more than once. So I'm going to think about this 45 and say if I go around the circle 360 degrees plus another 45, where am I at? Well, 45 plus 360 is 405, and 225 plus 60 is 585. So I basically went around the circle again. Now if you're thinking those angles are too big, you're right. Except that, remember, we're going to divide them by 2. So when we divide by 2, we get 202.5 and 292.5. And those are both within our range of answers that we wanted. So the bottom line is whenever you have these multiple angles, you need to go around the circle more than once. Here we went around it twice. Okay? In example number 6, how many times do you think you're going to go around it? If you said 3, you're exactly right. You're going to have 3 sets of answers. So try that one on your own, see if you can come up with the 3 sets of answers, and check them at the end of the PowerPoint. Okay. Example 7, 8, 9, and 10 actually all involve factoring. Now, when we factored before, we always started by looking for a greatest common factor, and we're going to do the same thing here. So we're going to look at these and go, what do they share? Okay. Well, in this case, these two share cosine theta. So we're going to factor that out. Okay. Cosine theta, when I factor it out, cosine theta times 2 cosine theta gives me my 2 cosine squared. And cosine theta times 1 gives me cosine theta. Now I can't factor any more, so at this point I have 2 smaller equations that I'm each going to set equal to 0 and solve. So I'm going to set cosine of theta equal to 0 and 2 cosine theta plus 1 equal to 0 and solve those 2 individual problems. Now cosine theta equals 0 is really saying x is equal to 0, and x is equal to 0 when the angle is 90 or 270. 2 cosine theta plus 1 is a little harder. I need to subtract 1 and divide by 2 first. And that gives me cosine of theta equals negative 1/2. So where is x negative 1/2? Well, that's in the second and third quadrant, and that's when the angle is 120 or 240. So I have 4 answers to this problem: 90, 270, 120, and 240. Right? Try example number 8. Notice that this has sine in common. So that would be what you'd want to factor out. Check your answer at the end of the PowerPoint. Example number 9 is probably our hardest example, and this also involves factoring. This one, though, doesn't have a greatest common factor. Notice that we've got sine in the first one and sine in the second, but no sine back here in the third. Now, please also notice that it starts with a squared and then has a single sign and then has none at all. This is really just a quadratic. It's just like x squared minus 3x plus 2. So I often will rewrite it this way and factor it with the x's that I already know and then put my signs back in. So if this one is similar to x squared minus 3x plus 2, when I factor it, I'm going to get an x minus 2 and an x minus 1. Now, I don't really want to be working with my x's, so I'm going to put my sine function back in. That's going to give me sine theta minus 2 times sine theta minus 1 equals 0. And again, I have 2 problems to solve. I have sine of theta minus 2 equals 0, so sine of theta is equal to 2. Now you might be asking yourself, why is that no solution? Well, remember, sine is y, so this is saying, where is y equal to 2? Well, we're working in a unit circle, and a unit circle has a radius of 1, so there's no way that y can be equal to 2. Right? Now that's pretty important, you might want to write it down. Sine and cosine will always be less than or equal to 1. We're working in a unit circle. X and Y can't be more than 1. So if you ever get a value for sine and cosine that is more than 1, you're going to have no solution. Now the second part of this equation is sine theta minus 1 equals 0, which means sine of theta is equal to 1, which is telling me y is equal to 1. Now if y is equal to 1, that happens where theta is 90, and that becomes the only solution to my equation. So this one, even though it's a squared, only has one solution, 90 degrees. Now try number 10 and see how you do. Number 10 is a little trickier because it's not equal to 0. So you might want to make it that way first. You might want to do 2 cosine squared theta minus 7 cosine theta minus 4 equals 0. Now remember, that's just like 2x squared minus 7x squared equals 4. Okay? Factor that simpler one first and then put your cosines back in. Again, try it. Here are the answers to all of the even-numbered or your turn questions. Hope you did well with them. If you have questions, we'll be talking about them in class.